Hey there, how are you doing? I hope you enjoyed my last video on selection sort. So today we'll be doing insertion sort, and you must be wondering what next. So as I told you, like I am getting back into the groove, so I need a way to get myself aligned with that. That's why I'm starting with sorting algorithms. But this is not the end. This is just the beginning, and it helps me to think in certain way, because these sorting algorithms do contain some logic, and once you are into it, you start thinking it. And I have done it before, so it helps me to catch that up really quick. So that's why we're doing sorting algorithm, and that's why I'm doing sorting algorithm. And once and I won't just keep it limited to sorting. I was thinking like we'll do it with TDD, which we already did. Then once we have more than one classes, some kind of patterns start to emerge. So we'll implement design patterns to make it more streamlined, more scalable, and it will also help to give. It will also give you a better knowledge about how things can be structured in a way that it is easier to scale and maintain. So once I'm done with this algorithm series, this sorting algorithm series, then I will start implementing some projects, and that will be fun and exciting. That's how we'll learn. So let's see, without wasting much time, let's dive into insertion sort. And yep, I'll think of something. Like in college we used to have a syllabus, so that is what I'm thinking about. So from next video I'll prepare some kind of syllabus, our roadmap about how we are going to proceed with that. Okay, so let's get going. See ya. Hey, so let's see how insertion sort works. I really need to refresh my memory. So what I remember is that we pick the first element, we scan through the array, and we compare it backwards. So we pick the number, we compare it backward. If we find a smaller number, we swap it, then we compare, then we go next, we pick the other number, then go back. So as you can see on the screen, so blue one is actually which is iterating forward, and then the pointer takes that number, compares that number, and goes backward. So it's hard. I think I'm not able to explain that well. So basically insertion sort says pick the number, keep comparing, go back, go back, go back, and once you find the number which is smaller than this, you stop comparing. So that is what insertion sort is. You insert the number in its correct position. So all the numbers to the left of your pointer will be sorted. So as you can see, the index 0 and 1 are sorted. So in each iteration, you put one number in its correct position. Okay, so I think we have got the understanding of how it works. So let's go and code it. Hey, so this is where we left off, and I just realized that we have made changes on the same input that we got from there. The problem with that is if I change my assertion from output to array, it should still work because we are changing on the same memory address, which we shouldn't do. So the fix would be simple. We can make a copy of this at our end, and we should actually do this every time. This can save us from a lot of small issues that come up in the code. So yeah, we'll make a copy of input array, and the length will be same. So now if I run the test, it should fail because we have copied the entire array into a different memory location. So no, we are no longer share the same memory location. So now we'll have to assert on the output that we get, and input is untouched. Great. So now I can close this. Okay, I can copy this one because this will be required in insertion sort. Actually, you can copy everything, and then I close these classes. I'll create a new one, and name it insertion sort. If you remember, Command Shift T. Yes, it will always create under test directory, and I'll paste that code here and just make few changes. So my selection sort will become insertion sort, and wherever I'm using insertion sort, I'll replace it with, let's see if Shift F6 works. Cool. With insertion sort. And then this method, we'll create it here, name it to input. We'll do same that we did with that, and array start copy. We'll create a copy of this input with the same length. Great. So now we have the array. Now we have to sort this array. So for insertion sort, we'll have I that will be set to 1 because we'll compare backward. So I'm starting with the first index and not the 0th index, and it will traverse till the length of the array. Then j will start from I and go backward. J less than greater than 0, j minus minus. So if j, the number on the right, is less than the number on the left, then we have to make a swap. So I'll assign jth to temp, then on the jth element I'll put j minus 1, and on the j minus 1 index I'll put the temp variable. So we are basically swapping the numbers, and this should do it. Let's see, we just have to return the correct array. I want, okay, let's run and see. Awesome. In the first go. Amazing. Great. This never happens, by the way. Cool. So now we can also optimize it. So if you remember, like once we, at every iteration, we are sorting the numbers. One number reaches to its correct position. Basically, so once we, so in the else block, we can actually break out of the loop. We don't have to go further down the line if we have found a number or place for that particular number. We have already swapped it. So let's see, our test case should still pass. Awesome. So this is insertion sort, and in the next part of this video I'm going to make this thing common. So this swap method is going to be used in more than one places, and also the structure of my class has started to look pretty much same that of the selection sort. So maybe there's a scope of improvement there because we're going to add more algorithms to it. So it's better that we have a particular set of contract on which they can follow or implement along. Cool. See you in the next part. Okay, so we'll create an interface for both of these classes. So to create the interface, I'm not going to write any code. I'm going to make use of the IDE. So you just have to click on the class, right click on the class, go to refactor, extract interface, and here you just have to tell the IDE which method you want to extract out, and in our case we want to extract out the sort method, and then the name of the interface. So name of the interface will be sort, and then click on refactor. Yes, so it will find and replace it everywhere in our class to refactor. So now as you can see, our insertion sort class implements sort interface and overrides sort method. Similarly, we can do it with the selection sort, which will implement a sort interface, which means this method is the one that we are overriding. Since the body is same, so we don't have to make any changes, and it works. And this is our interface. Great. Now we can do one more thing. We can abstract out this common logic of swapping two numbers on a given index. So I'll press Command Option M. This will extract out my method. I'll call it swap. But in this case, this is not very generic, because now what IntelliJ has done, since it was using only one variable, that is j, so it only took one variable and calculated the other one by subtracting it from j. But we will need two indices, so that we can make it generic. So we can pass two index with the array, and it will swap both of those. So I'll pass I here as well. Actually, this will be j and j minus 1. So I want to swap between these two indices. So this one will become I and the other one is j. So let's say, so wherever it says j, I will replace it with I. Wherever it says j minus 1, I will put j. So j minus 1, I'll put j. Cool. So now this swap method has been extracted out. Just to make sure if everything is working fine, I'm going to run that test case. This is why we have test cases, so that we can safely change our code and still have a safety net. So if anything goes wrong in the logic, we can always go back and redo it, because we have our test cases there to verify, okay, you made a mistake there. So always write test cases first. Great. So this swap method is working fine. Now we have to make it common so that it can be accessed by all the classes that uses swapping. So as a matter of fact, selection sort also uses swapping here. So how can we make it common for both the classes? Since we have an interface here, and I think since Java 8, we can put methods inside of these interfaces. So that is what we are going to use. I'm going to take this method from here, go to my sort interface and put it here. And this is going to be a default. Now this method is available to selection sort. You can run the test case again to see if everything is working fine. Cool. And then in the selection sort, we can call this here swap. We'll pass the array. We'll pass the last index and max index, and we are done. So if I run the test case for selection sort, it should pass. Great. So now we have extracted out an interface, because we were seeing a common pattern emerging. And now each and every sorting algorithm that we do going forward will implement this sort interface, and automatically will have to implement this sort method, and rest everything will remain the same. So far so good. And in the next video, when we are going to do another sorting algorithm, let's see, what do we have? We have merge sort. Great. So during that, we will also create a mechanism to calculate the time it takes to sort the entire input, and we'll make that generic too. So stay with me, it's going to be exciting. Till then, bye bye.